I'm Anil Kumar, and in this video we'll discuss a very important and fundamental question on solving trigonometric equations. The question here is, how many solutions are possible for tan 3 theta equals to square root of 3 when theta is between 0 to 2 pi? Solve and write the solutions, right? So first thing is, we need to understand how many solutions, and second part is we'll find the solutions themselves. So let's answer the first question. We have the equation tan 3 theta equals to square root of 3 where theta is between 0 and 2 pi. Since we know that theta has periodicity of pi and we are looking for a positive value, that really means that one of the solutions should lie in quadrant 1, right? And the other should be in quadrant 3. So in one circle of 0 to 2 pi, we get 2. But here the question is tan 3 theta equals to square root of 3. So if theta is between 0 to 2 pi, then how about 3 theta? For 3 theta, we need to multiply both by 3, right? Rather, all three of them. So we get between 0 to 6 pi. Do you see that? So it really becomes, the domain for 3 theta becomes from 0 to 6 pi, not just one circle. So in one circle we get 2. So this is like one circle, correct? Then we have another circle, that is 4 pi, and then another circle. That makes it 6 pi. So in 6 pi, how many solutions do you expect? That is the question, right? So the solution, you have understood that in every circle we get 2. So in 3 circles, we'll expect 6 solutions. So that's a very important concept to understand, right? Now in part B, let us solve and find the solution. So we have equation tan 3 theta equals to square root of 3. And the domain for us is, for theta, the domain is 0 to 2 pi, correct? That's the question. Now to solve it, we can always use calculator, correct? And find the solution. Or in this particular case, we can actually use our special triangle, right? So whenever possible, if you can, use special triangle. That will help you to solve trigonometric equations very easily, right? So remember this triangle? That is for pi by 3, pi by 6 and pi by 2, correct? Now from here you can see for pi by 3 we get square root of 3, right? So that is the related acute angle. So this acute angle here is pi by 3 for us. Now this pi by 3 is the first solution, but we have a couple of solutions, right? So we can say, well, tan 3 theta equals to square root of pi by 3. So 3 theta is tan inverse. So 3 theta equals to tan inverse of square root 3, right? Where theta is between 0 to 2 pi. Now all possible equations will be, first acute angle is pi by 3. And then it will be pi by 3 plus pi. Do you see that? Then it will be this point, which is, let me do it in a different ink right there, so that we'll do it here. Then we have pi by 3 plus pi, right? So when I write plus pi, I have to multiply by 3, divide by 3, correct? So let me write 3 pi by 3 to keep on adding it with. So when you add this, 3 plus 1 is 4, so we get 4 pi by 3. Is that okay? So the next one should be 4 pi by 3. And then again, I have to add pi to it, right? So when I add pi, that means again I have to add 3 pi by 3. You get the point, right? So it is 7 pi by 3. Is it okay? 7 pi by 3. Now again I have to add pi, that means 3 to this. So when I do that, I get 10 pi by 3. And then I get 13 pi by 3. 1, 2, 3, 4, 5. And let me write 16 pi by 3. And then we'll figure out whether these are correct or not. But all these are really equal to what? They're all equal to 3 theta, right? So what is the value of theta? So theta should be equals to, you have to divide them by 3. So we get pi by 9, 4 pi by 9, 7 pi by 9, 10 pi by 9, 13 pi by 9, and 16 pi by 9. So these are all the solutions, right? So theta is 16 pi by 9. Now, is still theta within 0 to 2 pi? Well, 16 pi by 9 is less than 2 pi, right? 2 pi is equal to 18 pi by 9. So it is still less than 2 pi. So we do have 6 different solutions for the given equation tan 3 theta equals to square root 3. Now this is a very important concept, and I hope you understand and appreciate it. And this is going to help you to solve most of the trigonometric equations while dealing with compound angles. I hope that helps. Thank you and all the best.